All right. This one really boils down to plug and chug. Let's take a look at 9.96. A big league fastball travels at a speed of 46 meters per second. At what temperature in degrees Celsius does a helium atom have the same average speed? This goes back to the very first formula you got for this chapter. Your root mean square speed is equal to the square root of 3 times the gas constant times temperature divided by the molar mass. Now, we said there were a couple traps for you in using this formula. The first being you're using the energy version of the gas law constant, so it's 8.314 joules, moles, Kelvin is your value for your gas constant because you're using the energy value here. The temperature in this formula is always in Kelvin, and that's the unknown for this equation, by the way, is going to be your temperature. The molar mass is the molar mass, not in grams like you're used to, but it has to be the molar mass in kilograms. And I think that's what throws a lot of people. So let's look up that molar mass of helium. I'm at its secret disclosed off-site location. So I have to take a second to look up my helium. Helium has a molar mass of 4.00262 grams per mole. So we're going to have to convert that to kilograms. Place grams where they cancel out. Place kilograms where we'll have them. So we wind up with a molar mass of 4.00262 times 10 to the negative third kilograms per mole. We have to use kilograms here, remember, to cancel out that joules. Refer to your lecture notes for why there. Your speed has to be in units of meters per second, and they were really nice enough to give us that in meters per second. So they already gave us meters per second. We have everything we need except for temperature, which is convenient since that's what we're solving for. So now it's just plug and chug. Whoops. Yeah, plug and chug there. So I've got, come on, stop that, 46 meters per second equal to the square root of 3 times 8.314 joules, moles, Kelvin times temperature divided by our molar mass, which is 4.00262 times 10 to the negative third kilograms per mole. So now it's a matter of resolving the algebra. First thing I'm going to do is I'm going to get rid of that square root sign. How do you get rid of the square root sign? You multiply both sides by it, right? So I'm going to get rid of that square root sign just a second. I need another, that's a good color. Oh no, that's even better color. Okay. So, whoops, that's a marker. So I'm going to get rid of that square root. Oh, come on, guys. Get with the program. Alright. So I'm going to square both sides to get rid of the square root symbol. so I can get to that t variable. I do that, and I have, stop that. I have 46 meters per second squared equal to 3 times 8.314 joules, moles, Kelvin, times my temperature, divided by 4.00262 times 10 to the negative third kilograms per mole. I have to get my variable by itself, so now it's just a matter of working the algebra again. And I'm going to multiply both sides by the reciprocal to clear it. So I'm dividing by that 4, multiply by that 4. And you wind up with, now you just have to multiply those terms, and of course, where is it? Come on. Right? That stuff has now all been crossed out, so you have t by yourself over here. And you're just going to punch all that into your calculator, and you're going to get, now remember, because of the way the units cancel, you're getting your temperature here in Kelvin. All right, 4.00262 EE negative 3 divided by 3 divided by 8.314 times 46 times 46 equals, whoa, equals a really, really small number here. Yeah, I'm doing good. It's going to give you a temperature of 0.339569558 K, or Kelvin. Now we've got to deal with our sig figs. They were really nice to us. If you look at what they did, the only number they gave us in this problem was that 46. Everything else we pulled from other sources, so it's that 46 that really limits our sig figs to 2 sig figs. So we've got 0.3396 Kelvin as our temperature. Now, for some troglodyte reason, we're going to have to reduce it to helium. We're going to have to convert it to Celsius, because that's what they asked us to do in the problem. That's no problem. We can do that like we're standing on our head. Remember, your temperature in Celsius equals your temperature in Kelvin minus 273.15. So my temperature in Celsius is going to be 0.3396 minus 273.15, and that is going to give me a temperature in Celsius of a negative 272.81 degrees Celsius. That's that.